Hello students, in this video I am going to explain Oersted experiment and Lorentz force. Electricity and magnetism both are known for more than 2000 years, but their relationship was discovered only 200 years ago. This relationship was given by a Danish physicist H.C. Oersted in 1820. Let us study this experiment. The magnetic effect of current was discovered by H.C. Oersted in 1820. He observed that flow of electric current through a conductor produces a magnetic field around it. For this, the setup is like this. There is a battery along with a switch, and the current is allowed to pass through the circuit when the switch is closed, and a magnetic needle is placed close to it. It has been observed that when current is flowing from south to north, the north pole of the magnetic needle deflects towards west, and when the current is flowing through the conductor from north to south, the north pole of the needle deflects towards east. The direction of deflection of the magnetic needle is determined by Ampere's swimming rule. According to this rule, if we imagine a man swimming along the wire in the direction of the current with his face always turned towards the needle, then the north pole of the magnetic needle will be deflected towards his left hand, and it can be recalled by the word snow, where S stands for south, N for north, O for over the needle, and towards the west. That is, when the current is flowing from south to north over the needle, then the magnetic north pole will be deflected towards the west. This deflection of the needle shows that due to the passage of the current in the wire, magnetic field is established around it. Also, by increasing the current in the wire or bringing the needle closer to the wire, deflection increases. So, this experiment shows that magnetic field is produced due to electric current. And what is current? Current is charge in motion. So, we conclude that moving charges produce magnetic field. This is written here. That a static charge produces an electric field, and a moving charge or current through a conductor is a source of electric as well as magnetic field. So now we are in a position to define magnetic field. It is the space around the magnet or current carrying conductor around which magnetic effects can be experienced. It is a vector quantity and its SI unit is Tesla or Weber per meter square. In CGS system, the unit of magnetic field is Gauss, and the relationship between Gauss and Tesla is that 1 Gauss is equal to 10 raised to the power minus 4 Tesla. Now let us discuss the magnitude of the force experienced by this charge, that is force due to magnetic field. For this, let us consider a charge, positive charge Q, moving in presence of the magnetic field B with a velocity V, making an angle theta with the magnetic field as shown. The force on the charge Q due to interaction between the moving charge, that is current, and the magnetic field applied is given by Q into V cross B. As the velocity vector is making an angle theta with the magnetic field, we are resolving this velocity in two components, that is V sin theta and V cos theta. V cos theta is along the same direction as the magnetic field, and V sin theta is perpendicular to the direction of the magnetic field. And we are aware that the resultant of the cross product of two vectors in the same direction is 0. So, the cross product due to V sin theta and B leads to the magnitude of the force F. which is perpendicular to the plane of B and V sine theta. This force is called as magnetic Lorentz force. There are special cases. If this theta is 0 degrees or 180 degree, then the force will come out to be 0. It means that a charged particle moving along or opposite to the direction of the magnetic field does not experience any force. And if V is 0, that is velocity is 0, or you can say the charged particle is at rest, then also it will experience no force. If the charged particle is moving at an angle of 90 degrees, then the force will be maximum. It means that if the charged particle is moving along a line perpendicular to the direction of the magnetic field, it will experience maximum force, and its direction can be calculated or determined by Fleming's left hand rule. Let us study this rule in detail. Fleming's left hand rule. It states that if we stretch the forefinger, central finger and thumb of our left hand mutually perpendicular to each other, such that the forefinger points in the direction of the magnetic field, see here, the central finger points in the direction of the current or motion of the charge, then the thumb represents the direction of the force experienced by the charge. Also, we are aware that when the charged particle is subjected to an electric field E, it experiences a force in the direction of the electric field only. That force is represented as QE. Let us see here. Suppose there is a charge Q. It is subjected to electric field along the x-axis and magnetic field along the y-axis. Then the force on the charge due to the presence of the electric field is QE, which will be along the same direction as the direction of the electric field, and the force due to the magnetic field as the charge is moving perpendicular to the magnetic field, the force experienced due to the magnetic field will be maximum, as we have just studied. This maximum force value is BQV sine theta, and theta here is 90 degrees. So, it will be BQV. And the direction of this force will be perpendicular to the direction of the plane of motion of the charge and the magnetic field. So, the resultant of this magnetic force and this electric force will be termed as the Lorentz force. That is, the force experienced by a charged particle moving in space where both electric and magnetic field exist is called as Lorentz force. Thanks for watching. Please like, share and subscribe.